Hello, today we're going to have a close look at one of the most important parts of our bodies. We're going to have a look at the heart. Now the heart is really important because it's the organ that pumps our blood around our bodies. And our blood is the way that every part of our body, our muscles, our skin, all parts of our body gets oxygen and nutrients like sugar. So oxygen and these nutrients are carried in the blood to all parts of the body, delivered to your muscles and other parts of your body. And then the blood will pick up waste products like carbon dioxide, take them back to your lungs where we can breathe it out. So the heart is very important. One time you may have noticed your heart is after exercise, the heart beats much faster. That's because the muscles in exercise require more oxygen and more sugar, more energy, and they make more carbon dioxide, which they need to get rid of. So to have a close look at the heart, one thing we can do is a dissection. So I have bought a lamb's heart. I bought it from the butchers. You can also buy them in the supermarkets very easily in the meat section next to the lamb chops. So I've got a lamb's heart, and for a dissection, that means we're going to cut it open very carefully to see what it looks like on the inside and see if we can figure out how it works. So let's get started. So here is our lamb heart. It is about the same size as my fist, maybe a little bit smaller. That means it's about the same size as my heart, because our hearts as humans are about the same size as our fist. So a child's fist will be a bit smaller because their heart's a bit smaller. A baby's fist is much smaller because their heart will be much smaller. So as we grow and as our hands and our fists grow, our hearts grow with us. So this lamb heart, you can see straight away the two main colours, the dark reddish brown colour and the paler whitish pink. You might recognise the reddy brown stuff because it's meat. It's the muscle of the heart. Now, most of the heart is made up of muscle, and all of the meat that we eat is muscle from different animals. So breast meat on a chicken is the chicken's muscles that it uses for flying. And the leg meat on a leg of lamb are the leg muscles that the lamb uses to walk with. So this heart muscle is just heart meat, the same as any other, which is why hearts are edible, which is why they're sold by the supermarket. The whitish pink stuff, touching it, I can feel it's much, much harder than the muscle. That's actually the fat. Now the fat, there's always a little bit around the heart, and it's actually there as protection. It helps to protect the heart as we're moving around and as the heart might get bumped around in our bodies. So a little bit of fat around the heart is a very good thing. But if there's too much fat in the diet and too much fat in the body, too much fat can build up around the heart, and that then stops it working so well. So we've got these two parts. If we have a look at the heart in general, first thing you probably noticed, it's not shaped like a love heart. I'm not sure where the love heart shape comes from, but apart from the slightly pointy bit at the bottom, there's definitely not those two bumps around the top. A real heart is a much more complicated shape. If we have a closer look at the top, we've got some tubes. So these tubes are really important for carrying blood in and out of the heart as it pumps it around. We've got some tubes sticking out, and then we've also got kind of some holes on the side here. So that's where the tubes have been mostly cut off, and we've just got the holes going into the heart. So these tubes are large blood vessels for the blood that's being pumped by the heart. On the outside of the heart, these lines are much smaller blood vessels, and these are the blood vessels which are delivering the oxygen and sugar to the heart muscle, because the heart muscle needs oxygen and sugar just like the rest of our muscles. So it needs some blood vessels, some arteries to take the blood to the heart, and some veins to carry the blood and the carbon dioxide away. So that's the outside of our heart. Let's have a look on the inside. Now there's different ways we could cut it. We could cut it across like that. We could cut it up and down like that. or you could cut it from side to side, right through the middle. We're going to try that last one because that should show us all the parts of the heart, although any of the others can show us interesting things as well. So I'm just using normal classroom scissors for this because it's not very tough material, so it's quite easy to cut. So first I'm going to cut up the side here, and I can feel I've cut through something already into a space in the middle. So we'll cut through this thin layer first, down to the bottom. And we can open this side up a little bit now to see that there's a cavity, there's a space inside the heart. So I've just cut through this fairly thin layer of muscle around the outside, and that then opens up to reveal a much shinier inner layer of the heart muscle. And we've got all these strings as well. And actually, I think we can just about see a bit of daylight through the top. So that's looking through some of the tubes that we saw earlier in the top of the heart. So that's one side of the heart. Let's carry on cutting round to the other side of the heart. So we'll cut through the bottom. Oh, now this side feels a bit harder to cut through. It's a bit thicker. So we'll cut up to the top. Let's open up this side and have a look. So you can hopefully see there's a much thicker layer of muscle that I've had to cut through. But again, there's another cavity in the middle with a very shiny inner surface and some of these strings. But these two cavities don't join up, they're separate. So there's an extra piece of muscle down the middle of the heart, which separates these two halves. We're going to cut that now though, to get our heart fully in half. And then cut around the top as well, to completely separate this top layer. Now the fat around the top of the heart is actually much harder to cut through. Part of the reason the fat is so hard is because it's cold. This heart has been in the fridge. In a living animal, it's going to be much warmer, and then the fat will be much softer as well. There we go. So we have taken off the top layer of the heart to reveal what we've got inside. Let's have a closer look. So we've got the thin wall of the heart on this side, and then the much thicker wall of the heart on that side, and a lovely layer of muscle down the middle that separates these two parts of the heart. Then we've got all these stringy bits. I can almost stick my finger under them. And actually, let's cut away a little more at the top here so we can see more clearly. These strings kind of connect to a stringy membrane, very thin, and they're tough. These are hard, these strings. I'm pulling on them really hard. They won't break, so they're very tough, these strings, very strong. So a few down the bottom here, and a lot more on this side. Oh, here we can see the membrane much more easily. So they're connecting to a really thin membrane inside the heart. The tubes that we saw from the outside, let's see if we can find out where they go. So we've got this tube here, if I stick my finger down it, it pops out on this side of the heart with the thick muscle. Let's try one of the other tubes. We've got this opening, really big one. That also comes to this side of the heart. What connects to this side with the thinner muscle? I'm going to go in the opposite direction this time. Stick my finger up through the top. See, it comes through the hole on this side. And there should be another hole further back. That connects to this one. So you can see the two holes are close together there that join to this side of the heart. So what do all these different bits do? Now, it's really helpful here to have a look at a diagram. So I'm going to move this top section of heart out of the way because we don't need that anymore. And let's compare our real heart to a diagram, an ideal picture of a heart. So at first glance, there might not be much similar between these two, but let's have a look through. You can firstly see on our diagram, there's definitely two halves of the heart. There's this half with the blue arrows. It's on the left-hand side, but we'd call it the right side of the heart, because the right and the left side of the heart are named depending on what they're like in your body. But now we're looking at someone else's heart in this picture, so they're reversed. So this side of the heart, you can see it shows it's got a really thin wall, while the left-hand side on the right has got a really thick wall. So that's exactly what we noticed when we first cut it open. There's a really thin muscle wall on this side and a much thicker muscle wall on that side. And the muscle down the middle as well that separates the two halves. Now, the top and the bottom of the heart are split into two sections, and we're going to follow that through by following the journey of some blood. So we're going to start with the blood that's coming back from our muscles. It's given away all of its oxygen, and it's picked up all of the carbon dioxide from the muscles that it needs to get rid of. It comes into the heart on this side through what's called the vena cava, and that's coming through a vein. All the veins in the body come towards the heart, carrying blood away from the muscles. So that vein carries blood into the top of the heart up here, and then it flows through. This is the atrium at the top, and then the blood flows through to the ventricle at the bottom of the heart. Now, these strings in the membrane are actually a valve. And what a valve does is it makes sure things can only go through in one direction. So the valve means the blood can come down into the bottom of the heart, but then it can't go back the way it came. It comes down, and when the heart beats, this bottom section of the heart squeezes shut, and it squeezes the blood out of this ventricle. It can't go back the way it came, so it's got to come out of the other tube up here. And this is called the pulmonary artery, and this takes the blood to the lungs. So this side of the heart is very thin because it only needs to send blood to the lungs, which is right next to the heart anyway. So the blood will come out of the second tube, out this way, will head to the lungs, and that's where it can get rid of all of its carbon dioxide and pick up some brand new oxygen to take to the rest of the body. So after the blood has gone round to the lungs, it comes back through what's called the pulmonary vein, which is this bit here, and it comes back this time into the left side of the heart, which we've got on the right. Just like the first side of the heart, it's got an atrium at the top and a ventricle at the bottom with some valves with these strings connected to a membrane in between, which means the blood can't go backwards. So the blood comes in from the lungs, comes down into the ventricle, and this time, when the heart beats, the ventricle will squeeze. It's got much bigger muscles this time because it needs to squeeze the blood up through here, up through this set of tubes, which is called the aorta. These blood vessels are arteries that take the blood right round the rest of the body. So this side of the heart needs to be much stronger because it needs to be able to pump its blood all the way around the whole body. And the aorta splits into several tubes because one will go up to your head, one will go to your arms and your body, one will go all the way down to your legs. So this side of the heart needs to be able to pump your blood right around your body, which is why it needs to be so much stronger than the side of the heart, which just pumps to the lungs. So that's the journey our blood makes, going through all the parts of the body. Now, this big bit of muscle in between the two sides of the heart is really important. It's called the septum, and it separates the blood on this side, which has got no oxygen, it's deoxygenated and needs to get sent to the lungs, from the blood on this side, which has already been to the lungs, so it's full of oxygen, it's oxygenated, and is going to be sent around the body. It's really important that the blood on these two sides doesn't mix. Sometimes it does. Sometimes animals and children can be born with a gap in this part of the heart. It's called a hole in the heart. And that then means that blood can mix between the two halves, which is not good, because that means some of this deoxygenated blood with no oxygen, instead of going to the lungs, will go through the septum, will go through this bit here, and will go around the body again, but it doesn't have any useful oxygen in it. And blood from this side of the heart, that's full of oxygen, ready to go around the body, will go through the septum and will get sent to the lungs again, but it doesn't need to go back to the lungs because it's already full of oxygen. So humans and animals with a hole in the heart, they don't have much energy because they're not getting as much oxygen to their muscles, but luckily it can be fixed. Doctors, heart surgeons, can do an operation when the baby is maybe a year or two old, when the heart is big enough, to fix up the hole in the heart, and then they can go on to live a normal life. So that's the heart and the importance of it. If you want to do this at home, it's very easy to get hold of a heart. They sell them in most supermarkets. It's meat, so you need to be careful because raw meat can have bacteria in it that can make us ill. But just like when you're cooking, so long as you wash your hands after you've handled it, it's perfectly safe to do. You can cut it up with scissors like I did. And if you really want to, if you cut it up with clean hands, you can even cook and eat the muscle, the meat afterwards. So that's our heart dissection. I hope you enjoyed learning a little bit more about the heart and how it works, how it pumps blood around the body. The heart is one of the hardest working muscles in the body because it's pumping all the time, and it is a crucial part of the body because it moves the blood around and the blood supplies all the rest of our body with what it needs. The heart has to work harder during exercise, which means it gets stronger. Like any other muscle, the more it gets used, the stronger it works. And the stronger it is, the less hard it has to work. It's kind of a good cycle of the heart getting stronger and more efficient through exercise. Thank you very much for watching.